It's summertime here in Washington, D.C. Temperature is about 90-something degrees. The sun is beating down. It is hot.
Woo! He is not kidding. The last few months have been the hottest on record, and it looks like 2016 is going to be another record year. Hello, I'm Simon Edelman.
And I'm Paul Lester from Energy.gov. Simon, let's go inside and have lunch.
We're standing inside the Energy Department cafeteria, where it's definitely not hot. In fact, it's kind of freezing in here.
Yeah, I've got a couple goosebumps. I even see a few folks wearing sweaters in here. Let's go talk to them.
Can you tell me why you're bundled up?
I'm wearing a pretty thick poncho because it's very cold in the building.
There's like 2 people in our office currently that have like space heaters like set up in their office space just to like bring the temperature back to a normal level, like closer to like 70 as opposed to 65.
How cold do you guys think it is?
Well, in the building, it feels like it's about 60 degrees. Outside, it was pretty hot walking over here. It felt like it was about 90.
What's the feeling like coming from the outside in?
Well, it was a bit of a shock, but unfortunately, I've learned that this is how it is at work. I usually bundle up and I have a scarf wherever I go, and then when I go outside, I just sort of take off the layers.
Is this something that you see as a common problem, like not just here, but other places?
Yeah, I mean, I think it's the culture to have sweaters at work because people complain that it's just too cold and there's no way to adjust it. So in a lot of our meetings, we grab something hot to drink and we bring our sweaters. That's like what we do.
To each his own, because for me, this is very comfortable. Matter of fact, I probably would have my fan on top of this because I like cool air.
If you guys could imagine the future, and what do you think would be something that you would like to see?
I want more automation technology. So like I walk in, my smartwatch senses my skin temperature, and maybe the infrared camera in the ceiling panel says, oh, Greg's a little hot today. We're gonna like cool it down. And then I get a little cold. I reach for my shawl. The camera says, oh, no, we need to heat it up a little bit. It's wired and integrated into the building systems, and it just kind of does it for me. And maybe I say, hey, Siri, can you adjust temperature? And it's like, just takes care of it all.
If you had something like a little personalized robot following you around, would that be something that you would find interesting or distracting or like?
I don't want
totally
anything following me around.
Love a heating and cooling robot to follow me. That would just be amazing. There are just so many possibilities with a mini heating and cooling robot, many apps I can, install in there. Like, you could do a lot of cool stuff with that.
Sandwich too. Like, I'm hungry now.
Hey, cooling robot, go get me a sandwich.
Yeah.
Now, this problem is by no means unique to Energy Department headquarters. Anytime you're trying to regulate the temperature of a big space like this, someone is going to be left out in the cold. Or inside in the cold. Whatever. All across the country, people are wrapping themselves in blankets at their desks or fanning themselves to stay cool.
I mean, there's got to be a better way, right? Luckily, there is. And today, we are exploring technologies that could revolutionize the way we stay cool. So buckle up, everybody, because where we're going, we don't need roads. It's time for a trip to the future.
All the
The Department of Energy does.
The purpose of this is to show you how to use your imagination.
A foundation in science, technology, engineering, and math.
Developing these technologies for science.
Climate change.
We're talking about energy.
Big dreams can happen. Clean energy is wave of the future.
This is Direct Current.
Hello, and welcome to another episode of Direct Current, an Energy.gov podcast. I'm Allison Lantero.
And I'm Matt Dozier. And as you just heard, today's episode is about that all-important luxury during scorching summer days: air conditioning.
Direct Current producers Paul Lester and Simon Edelman will be serving as our fearless guides to the future of cool. From magnet-powered air conditioning to your very own robot that will actually follow you around to keep you nice and cool.
Paul, Simon, over to you.
Thanks, Matt. So when we say the future of cool, we're talking about the next generation of cooling systems or air conditioners.
We know this isn't the hottest topic, but stay with us because we're going to make air conditioning cool.
We take them for granted today, but in the future, air conditioning will need to change pretty drastically in order to address 3 big issues: climate change, cost, and comfort. We're calling them the 3 C's of cooling. And there are some extremely cool technologies on the horizon that could completely change the way we think about cooling.
Paul, before we travel to the future of cool, let's take a trip back to the past. To a hot, humid, swampy, and well, very Florida summer.
It's 1845, and Florida physician and inventor John Gorey proposes the idea of cooling hospitals to relieve patients of, quote, the evils of high temperatures. He believes that cooling is the key to avoiding diseases like malaria and making patients more comfortable. But his rudimentary system for cooling hospital rooms requires ice to be shipped all the way to Florida from the frozen lakes and streams in the northern United States. Imagine the logistics of that. Transporting huge chunks of ice, hundreds of miles, just for some ice cubes. So Gorey designs a machine that creates ice using a compressor, powered by a horse, water, wind, or steam. He's granted a patent for the design in 1851. However, this invention is ultimately a failure, primarily due to the death of his chief financial backer. But it sets the stage for air conditioning in the United States.
Fast forward to 1902. 51 years later in upstate New York, a 26-year-old Willis Carrier lands his first job at the Buffalo Forge Company. He's bright-eyed and fresh out of engineering school when tasked with solving a humidity problem that's causing magazine pages to wrinkle.
So Carrier devises a system that removes moisture from the air, which is really effective at keeping the printer's pages from crinkling, but also has another effect, one that turns out to be way more significant. It cools the air down. This becomes the first modern electrical air conditioning system. It's literally the coolest invention since...
Well, it actually was invented before sliced bread, so you can say that sliced bread is just as good as air conditioning.
That's Tony Buzza. He's the Water, Heating, and Appliance Technology Manager for the Energy Department and a leading expert on cooling technology. More from him in a bit.
Meanwhile, Carrier goes on to debut a new and improved system with fewer moving parts, which will become the foundation of modern-day refrigeration and air conditioning. Carrier's breakthrough increases the reliability and lowers the cost of large-scale air conditioners, greatly expanding their use throughout the country. In a very short time, air conditioning revolutionizes basically everything. For instance,
in 1925, the mercury is mounting and the sidewalks are simmering. Willis Carrier installs his cooling system at the Rivoli Theater in Times Square. It's the first time air conditioning is used in a movie theater, and the system is out of this world. Everybody wants to be the coolest person in town. They flock to the theater to escape the New York City summer heat and enjoy silent film stars like Charlie Chaplin in the glorious, chilled comfort of an air-conditioned motion picture theater. Over the next half-decade, Carrier's cooling system is installed in over 300 movie theaters across the country. It completely changes the motion picture industry, turning the once lackluster summer box office upside down. The rest, as they say, is history.
Well, not quite. Eventually, central air conditioning systems get smaller, more affordable, and installed in homes across the country, making it bearable to live in hot climates like Florida or Arizona.
All right, so Paul, how does air conditioning even work?
So the basic principle behind air conditioning is evaporation. When a liquid evaporates, that is, turns into a vapor, it has a cooling effect. That's what happens when you sweat, by the way.
Oh.
For air conditioning, the whole emphasis is to move heat from inside a home to outside, and that's how you provide the cooling.
Tony's right. And inside every air conditioner, there are metal coils filled with a chemical called a refrigerant. A refrigerant's job is to cool you down by taking heat from the air in your home and moving it to the outside.
Okay, but how does it actually work?
Let's follow the refrigerant journey step by step, starting at the compressor. That's what makes the mechanical hum you hear when the AC kicks in. It might sound counterintuitive, but for the air conditioner to produce cold air, you first need the compressor to heat up and pressurize the refrigerant until it's a hot gas. From there, it travels through one set of coils on the outside of the AC unit, called the condenser, where it cools and turns back into a liquid, releasing heat into the outside air in the process. Then the liquid refrigerant heads back inside, into another set of coils, called the evaporator, where it does just that. It evaporates, turning back into a vapor. This happens really quickly, and it makes the coils extremely cold. Then a fan blows air over the coils, chilling the room down to your desired temperature. And after that, the refrigerant goes back into the compressor and the cycle starts all over again. This process is called vapor compression. and it's basically how every air conditioner has worked since the days of Willis Carrier.
Wait, so all the air conditioning systems on the market today pretty much function the same way they have for 100 years?
Right. And let's just take a moment to let that sink in. The air conditioning technology we have today operates the same way it did 100 years ago. That's not a good thing. We need to make it better. This brings us to our first C of cooling, climate change. So those refrigerant chemicals we were just talking about, they are actually pretty harmful to the environment.
Ozone in the news. They say increased ultraviolet radiation through a hole in the ozone could raise temperatures, damage farm crops, and cause a lot more sunburn. Some scientists think the ozone layer is weakened by chemicals called chlorofluorocarbons, known more simply as CFCs. Now, with an eye on what's happening over Antarctica, some scientists want a worldwide ban on all uses of CFCs.
It turns out CFCs and similar chemicals like Freon, used widely at the time for air conditioning and refrigeration, are directly linked to ozone depletion. So in 1987, the whole world came together to address this environmental crisis.
It's being called an unprecedented display of international cooperation to protect the world's environment. The Montreal Protocol, signed today, aims at stopping the deterioration of the ozone layer in the atmosphere.
197 countries signed, with the goal to phase out CFCs. It was the first UN treaty to achieve universal ratification, and it was a big success, as the ozone hole shrunk dramatically by more than 4 million square kilometers. That's about the size of India, and a full recovery is expected by mid-century.
The Montreal Protocol improves the odds in the risky game the world has been playing with its own future.
So that's good news, right?
Well, there's good news and bad news.
All right, give me the good news first, though.
As these ozone-depleting chemicals were phased out, hydrofluorocarbons, or HFCs, became the new refrigerant of choice. That's the good news. HFCs performed well and were significantly better for the ozone layer.
But
they were later found out to be linked to climate change.
Oy vey.
Yeah, not great, right? HFCs are, in fact, the most potent greenhouse gas, hundreds to thousands of times more powerful in warming the planet than carbon dioxide. Now imagine nearly every air conditioning system in the country, and all over the world, using these chemicals. And if those chemicals leak, that's a massive problem.
Okay, I get it. So what do we do about it? How do we get away from those old harmful technologies and to the future of cool?
Well, that's exactly what Tony and others here at the Energy Department are working on. Their search for alternatives to traditional vapor compression cooling has taken them in some pretty interesting directions. For example, some researchers are using electric fields to cool things down. Others are testing the cooling properties of magnets.
And then we're also looking at elastic caloric, when you actually can change the temperature of something just by stressing it, pulling it apart. You could almost say like a rubber band that if you stretched it, it will warm up, but then when you release it, it actually will get cooler.
So these are called solid-state technologies, and they're potentially game-changing. They come in many different flavors using different properties of physics to create a cooling effect.
Sorry to interrupt. Did you just say that you can create air conditioning using magnets?
Yes, indeed. Science is literally cool.
Nice. All right, carry on. Sorry about that.
Most people as kids played around moving magnets around, and then you move it over a surface and you're actually changing the field. But one of the things when you have a magnetic caloric material is that there's a change in temperature.
And these magnetocaloric or magnet-powered cooling technologies already exist. In fact, the Energy Department's Oak Ridge National Laboratory in Tennessee is one of the pioneers.
We have been working on this for more than 5 years now, and we have been collaborating with people in the industry and material scientists.
That's Omar Abdelaziz.
I am a senior research staff at ORNL at Oak Ridge National Lab, and I work on building equipment research, and we are sincerely interested in activities that are related in energy savings, emission reduction, and demand response.
Omar and his team of scientists are developing the first ever magnet-based air conditioner, which could become the next big thing in home cooling.
I see that magnetic cooling has a great potential. It is still a challenging project because there is a lot of engineering issues that are yet to be solved. But from a scientific point of view, it is proven to be energy efficient and environmentally friendly.
And unlike today's air conditioners, the cooling system Omar's team is developing cools air in a much different way.
So magnetocaloric materials are the refrigerants. It's a solid refrigerant, basically. So you are not using any more gas, any more refrigerant.
So, no refrigerants. The only thing magnet-based cooling tech needs is some sort of liquid to simply move heat outside of the system. This can be either water or glycol, which is an odorless, colorless, non-toxic organic liquid. Way better for the environment. Another plus is that magnet technologies are way more energy efficient, and they use fewer parts than existing technologies. You won't need compressors or any other components you see in today's air conditioners. This makes them much more quiet and easier to maintain. This brings us to our second C of cooling, cost. Improving the efficiency of century-old technology can lead to big-time savings for consumers. This is one of the key focus areas of the Energy Department, getting innovative products into the marketplace so they are accessible and affordable for everyone.
We wanted to learn about another of these promising technologies, so we visited Exergy Incorporated, a small high-tech company located in Seaford, Delaware.
Hey, our friends are here. Welcome, you and Paul.
Exergy is just one of thousands of companies across the United States that have participated in the Energy Department's Small Business Innovation Research Program, or SBIR. The federal program helps small businesses like Exergy conduct important research and development in order to bring their energy technology of tomorrow to the marketplace today, or, in the near future.
We wouldn't be here without the DOE. I mean, it's that simple.
That's Bamdad Bahar. He's the founder and president of Exergy.
So in 2009, I filed my first patent in this area. The following year, I submitted the idea to GE for their Eco-Imagination competition and won it. But they thought it was a little too early stage for the kind of investments that they like to make. So GE was the one who actually said to us that, look, you really should be looking at a DOE, maybe an SBIR grant to be able to push this technology forward.
So Bamdad did look into it and thought his small energy business would be a good fit for the program. He applied, and Exergy got in. This helped jumpstart the company and make his idea for electrochemical compressors for cooling a reality.
So what do you do if you have these ideas? How do you invest in these sort of technologies that could be incredibly good, could be a total bomb, And I think the whole idea of having a small phase 1 SBIR and then a phase 2, if you prove the technology, if you meet certain goals, I think is a really clever, really smart process that the U.S. government has that, quite honestly, really, truly doesn't exist in the same way anywhere else in the world. And I think it's a huge competitive advantage for the United States.
Exergy is developing a new type of air conditioning compressor inspired by hydrogen and fuel cell technologies that can replace nearly all the expensive parts we need to run current air conditioning systems. Scott Fackler is a former physics teacher and one of Exergy's production managers. He showed us around.
What made your decision to get out of the education space and then
I like playing with cool toys. We got laser cutters and compression molding machines and all sorts of cool stuff to play with.
Scott, what are we looking at here?
This is the main stack, and it's a hydrogen compressor with 0 moving parts.
With Exergy's system, a small amount of lightly pressurized hydrogen is pumped through a material that's thinner than paper, called a proton exchange membrane. This creates an electrochemical reaction that produces cold.
Like the magnet-based system Oak Ridge Laboratory is working on, Exergy's platform doesn't use refrigerants. So from a climate standpoint, it's a massive improvement. Since the technology has 0 moving parts, it makes it easier to maintain and way more cost-effective for consumers than the traditional air conditioning systems in the long term.
Exergy's hybrid electrochemical compressor could be used in lots of other applications in your home, not just air conditioners. A hot water heater, for instance, could lead to even bigger energy and cost savings across the board.
Something like 8 to 10 million hot water heaters sold a year. If they all converted to hybrid hot water heaters, the savings in terms of terawatts of energy produced would be astounding. Roughly about 3 terawatts of energy savings in the country. I mean, almost a 3 to 5% improvement.
When you say like that 3 to 5%, are you talking
of total energy demand? Like you could basically eliminate the electricity production in the state of Oregon. That's how much electricity we're talking about if they all got converted into hybrid hot water heater. So it's a massive energy savings.
There are, of course, some hurdles. But fear not, The road ahead looks promising for Exergy's technology. What does the future of cool look like to you, and when do you first see the air conditioner, ballpark?
5 to 10. To be realistic, 5 to 10 years. But there will be cooling applications that will emerge before then, but may not be in the consumer realm, but it'll be in industrial applications. There'll be little niches, little pockets where the technology will be have value even if it operates for a relatively short period of time.
One of these little niches is driving down costs for consumers and helping reduce carbon emissions. This is why the SBIR grant is so important.
It's high risk, but it's high payoff. The opportunity to create something really significant that whether you do it or somebody else does it is going to have a massive impact. That's huge, and it's exactly what the DOE wants, right? To allow this innovation to happen and create new industry and new opportunities for us. It's a win-win. It's a win-win.
Get comfy because
we're on to our third and final C of cooling, comfort. So some of the people we talked to in the cafeteria at the beginning of the show didn't seem very comfortable. But that's to be expected when you take a one-temperature-fits-all approach to cooling. But what if it was more personalized?
You mean personalized like a little robot that follows you around and knows exactly what temperature you prefer, one that can heat or cool the air around you to keep you perfectly comfortable at all times?
Yes, if only something like that existed.
So why would we want to cool entire buildings when only the people need to be comfortable?
That's Reinhard Rademacher, a professor at University of Maryland's Center for Environmental Energy and Engineering. Reinhardt leads a team that has developed what they're calling the Roving Comforter, or ROCO for short. This could do everything we just talked about, and more. Simon and I dropped by the campus and sat in during a brainstorming session to talk to the team and learn about the project.
Yeah, you said you can test both at the same time. So we should have one heating and one cooling. We get experience with both of them as early as possible. And what would be the most convenient part of personal cooling? So to have it wherever people are, and a device that would be at least mobile or maybe even able to follow may be the answer. So that's what we came up with.
The ROCO is like your very own personalized robotic minion. It's a pint-sized R2-D2.
These aren't the droids we're looking for.
It has a nozzle at the top, a cooling system in the middle, and a platform with wheels at the base. Do you remember those Roomba vacuum cleaners, the ones that would spin around, bump into walls, and then your cat would ride on top? Well, imagine that, but the height of a standard desk. And instead of cleaning your floors, it cools the air around you. Essentially, you program it to hover around you and deliver the exact amount of cool you need to stay comfortable.
The ROCO and personalized cooling technologies like it are an entirely new approach to cooling. This is what we're talking about when we say the future of cool.
In the extreme case, maybe air conditioning wouldn't be needed at all, not air conditioning of the house as an entire building.
So the ROCO has big plans for additional features that would make it a whole lot smarter than your average desk fan. Features like wireless connectivity, the potential to tie into your home thermostat, even a home monitoring system.
The University of Maryland team imagines little ROCO robots roaming around cooling you, not just at your office and home, but other places like warehouses, nursing homes, healthcare facilities, and construction sites. Imagine that. We wanted to learn more, so we talked to Jennifer Gerby at the Energy Department's Advanced Research Projects Agency, Energy, also known as ARPA-E.
We use about 40% of all energy in buildings, and about 40% of that is heating and cooling. So it's a ridiculously large slice of the pie. So at ARPA-E, we like to look at the large slices of the pie, so that makes a lot of sense to focus there.
ARPA-E is supporting a whole slew of personalized comfort innovations through its Delta program. That's short for Delivering Efficient Local Thermal Amenities. Jennifer is the program manager.
In the Delta program, there's a couple different ways of looking at how to achieve that.
They're developing cooling and heating technologies like programmable office chairs to keep you cozy at work and clothes that auto-adjust temperature to keep your body comfortable.
Smart fabrics, and that can be responsive to the temperature in the environment. And then the other one is more looking at directly heating or cooling a person with something like what you would think of as a localized air conditioner or heater or something like that. The heating part is easy. We all know space heaters. The cooling part's what's really hard. So there's a couple of groups working on using these phase change materials to store energy during the day, let it out at night so that they can blow cool air but not be connected to anything.
So Paul, when do you think we'll get these cool, smart fabric shirts?
Well, Simon, that's the one thing we haven't talked about yet. How are all these cutting-edge technologies actually going to make it from the research lab and into your home? This is what the Energy Department is really focused on. For instance, ARPA-E provides each project team with a tech-to-market advisor.
And they help them do things like understand what would it mean to spin off a company? How do you put together a pitch deck? How do you approach other companies to maybe be a technical partner? And that's always evolving and changing. And in a program like Delta, which is very market-facing and very market-sensitive, that's even that much more important.
In a way, they kind of act like a social network for energy tech companies.
We'll introduce groups together. We'll say, you really should talk to this person who could help you in this area. A lot of what we do is bring a community together of people that usually wouldn't talk to each other.
Once it gets into the marketplace, you may see one in your office in the near future.
The idea of having a personal air conditioner that you could plug in at your desk is huge. Something like that's pretty game-changing because it doesn't exist now, and that's something that I can truly visualize coming down the pike in, just 2 to 3 years.
So whether it's a technology that will cool yourself or an entire building, scientists and innovators are tackling today's energy challenges and working to make a big impact on the future of cool.
It sort of makes me crazy that these problems that I consider that are very, very low-hanging fruit problems, we still haven't solved. We're sort of insatiable energy users, but we also have to appreciate the fact that we don't want our user experience to change. We don't want to notice that we're using less. We can use technology to achieve that.
What gets me most excited is finding a solution that would save energy, result in sustainable environment for my kids and future generations to come, be cost effective such that the cooling or the utility can be not only used by people who can afford it here in the US, but can be broadened and used elsewhere in the world.
My job is making sure that products get into the marketplace. It does no good to develop something in the lab if it doesn't get deployed. It's all about moving things into the marketplace. Commercialization is how I look at myself as being successful. From morning to night, we'll be able to touch their lives, and we really are excited about what the future has to offer and what Building Technologies, the office itself, is contributing to the American people.
I think we have a really good shot at being a successful business. It's not the money, it's more the opportunity to create something very significant that that keeps me up at night, let alone gets me out of bed in the morning. But it's just amazing that we live in a country, I think, where there are things like these programs at DOE that can support all this. And we're really very lucky, I think, privileged to be able to be part of it.
So we took you to the future of cool. And now we're back to the present.
We hope you enjoyed the journey and learned a little something about a technology that you use every day.
That wraps it up for this episode of Direct Current. You can explore the history of air conditioning, see photos of the technologies we talked about, and watch what happens when the Roco met the real-life R2-D2 at Energy.gov/podcast.
And if you have questions about this episode or any episode, you can email us at directcurrent@hq.doe.gov or tweet at Energy. If you're enjoying Direct Current, help us spread the word. Tell your friends about the show and leave us a rating or review on iTunes. We appreciate the feedback.
We'd like to give a big thank you to Jennifer Gerby from ARPA-E, Omar Abdelaziz from Oak Ridge National Laboratory, Tony Bouza and Nate Shelter from the Energy Department's Building Technologies Office, Bamdad Bahar, Scott Fackler and the staff at Exergy, and the University of Maryland's Roco team, led by Reinhard Rodermacher. Last but not least, thanks to our fellow Energy Department employees who vented about how ridiculously cold it gets in our office during summer.
Direct Current is produced by Matt Dozier, Simon Edelman, and me, Allison Lantero, with segment producer Paul Lester. Art and design by Carly Wilkins. Support from Pat Adams, Atiquar H., Daniel Wood, and Ernie Ambrose. Special thanks to our intern, Cole Edick, press assistant Annie Orloff, and our boss, Marissa Newhall.
Thanks to John LaRue, the Energy Public Affairs team, and the DOE Media team. We're a production of the U.S. Department of Energy and published from our nation's capital in Washington, D.C.
Until next time, thanks for listening.